Hey guys, I'm starting to work on the Philco 643 radio chassis. First I removed the tube shields and tubes and put them aside for safekeeping, and then I removed the plastic dial face and the little cover that goes in front of the backlight for the dial. Again, to keep them out of harm's way while I work on the set. Next I'm going to remove this whole tuning assembly. If you recall, the three mounting rubber grommets have all gotten rock hard and shrunk. So this is not only loose, but it's also sitting down too low in the set. It'll also be easier to work on the set with this out of the way. I'm also starting to clean the chassis, and I used 409 multi-purpose cleaner at first, which helped out a bit, but then I started encountering areas like this, which at first I thought might be corrosion, but it turns out it's some kind of like tar substance, which is actually a great thing because it prevented any rust, and it's actually fairly easy to get off too. I found that paint thinner works quite well, so I dipped a little Q-tip in some paint thinner, and if I just apply it, work it in a bit, starts dissolving it right up, and there's nice clean metal underneath. So, shouldn't take me too long to finish cleaning all that off. And then I'm going to start, I think first I will check the continuity on the antenna coils, the RF coils, the IF transformers, and the audio transformers. Especially the audio transformers, because if these are bad, I'm going to have to start searching for some replacements. These, if they're open, I can rewind. I've done that in the past couple radios I've worked on. And then we can move on to the recapping. I got most of that tar off, and the chassis is looking a lot better. The worst areas are actually where there wasn't any of that tar goop, and it has rusted a little bit, but nothing horrible. So now I am moving on to testing some of these transformers. I'm going to start off with these two guys, which are on the schematic here and here. So this has a primary and then a center tap secondary, and that drives the twin triode output tube, which is going to another center tapped transformer, but this time the center tap is at the primary and the secondary goes to the voice coil. This transformer is this guy, and this is the other one. Wires are fairly easy to trace out, so those two thick black wires right there, those are the output wires going to the voice coil on speaker. I'll grab a meter and start checking these and keep my fingers crossed. The DC resistance for these transformers is not marked in any schematic that I can find, but from experience I've got some sense of the values I should find. For example, I'm starting here, which is the output going to the voice coil. That should be quite a low impedance because it's driving a very low impedance load, and indeed I'm getting nearly zero, so I think that's alright. It's certainly not open. So let's check the secondary side. The center tap goes over here, and it's actually going to one of the battery terminals. And I've already traced that out, and it's this guy up here on this filter capacitor. And the other two are going right down to this audio output tube here. That's the two plate connections, these two tan wires. So let's check this guy. And I got about 315 ohms, which is promising. The secondary is going to be a lot higher impedance than the primary is going to be a lot higher impedance than the secondary. So high impedance tube output to a low impedance voice coil. It's center tap, so I should get about the same resistance on the other plate. So let's see. Just this guy, I think. That's not a good sign. I'm measuring infinity. Double check, so it's definitely got it on this wire. Going up here, here. Yeah, it's going right into the transformer there. Crap. Well, maybe there's a break inside this insulation, or maybe there's a simple break inside the transformer housing. I think what I'll do is unsolder these wires and unmount the transformers and get a better look at it. In the meantime, go ahead and check that other transformer. Now, the funny thing is, if that audio output transformer is bad, it's not the worst thing in the world, because if you recall when I talked earlier about the speaker that I picked up, it actually has the audio output transformer mounted on the frame. And the 643 schematic, it says right here, output transformer on speaker. That's why I was surprised to find it mounted on this chassis here. So, worst case scenario, I could bypass this transformer, rewire the socket a little bit, and plug this right into it and use this audio output transformer. Assuming that one's good. That just occurred to me, I haven't actually tested that, I just checked the voice coil on it. So let's do that right now. If they're both bad, well, they're both bad and unrepairable. I'm going to have to start begging online to see if anybody's got one. I spent a little more time poking around this connector and figured out that the pin with the white alligator clip on it is the center tap, and these two are the other sides of the winding. So one leg, we've got 318, and on the other one, we have about 359. I thought they'd be close in value, but then again, this is DC resistance, which is not the same as AC impedance. The important thing though is that I've got about equal values on either side of that center tap. So I don't think I have any shorts, and certainly no open winding, so this should be okay, unlike this one. Now let's check that other transformer, which is down in here. So I think this is one side and the center tap. It's going over to here, and sorry, this is the primary here. So one side goes there, and one side goes here. Alright, that's good. It's not shorted, and it's in the ballpark of what I expected to see. Now the other side is center tapped, and that's what drives the grid on the output tube. So this acts like the phase inverter to drive a push-pull amplifier. So this guy, okay, that's one, that's the other. So this is the center tap. And then here's one grid. Alright, about 160 ohms. And the other side, about 176. Alright, so nothing seems to be shorted or open on that transformer. Which leaves all the IF transformers and so on. Unfortunately, again, none of these resistances are labeled. And there are quite a few of them. So I will start going through those, and I will unmount that output transformer. Let's see. So there's one lug on either side. So I can unsolder the leads going to it, unmount the transformer. I think it's just crimped together. On larger transformers, sometimes there are a couple bolts, one on either side, that hold that clamshell on top of the transformer. I think this is just held on by pressure and bent seams. Well, I've got nothing to lose by trying to open it up. After the grain filler dried for a couple days, I lightly sanded the whole front with 400 grit sandpaper, and now I just applied some Minwax Special Walnut Stain. And it's been a couple minutes, and now I'm going to start wiping it off. And I think that's going to work out really well as the final color. So I'll let the stain dry for another couple days, and then move on to lacquer sanding sealer, and so on. So if you wonder why do I work on so many projects at the same time, well, this is one of the reasons. When you do refinishing, you quite often have to wait 24, 48 hours between coats. So I got to work on something else to kill the time. I unmounted the output transformer and double checked the resistance readings, and unfortunately there is indeed one open winding on this. These transformers are packed with tar, which is where all that tar came from that was on the chassis. That's going to make it very difficult for me to actually look for a broken winding. I would have to melt all that tar out, so I'm not going to bother with that. I'll just use the output transformer on the speaker frame. And I'll post in the classified section of the Antique Radio Forum to see if anybody has a 32-7472N. Now I noticed that these wires were soldered on kind of crudely, and when I posted a picture of this transformer at the Philco Radio Forum, Ron Ramirez, the Philco guru, pointed out that it has a date code of 1139, which is about 4 years after the radio was actually manufactured, so this is actually a replacement. And he says it's kind of uncommon for an output transformer to go bad, and in this case 2 of them have gone bad. So I hope that's not going to lead to problems down the road. Maybe somebody was using too much voltage to try to boost the output of this or something. I don't know, but definitely be careful when I get this radio restored and playing. I'll keep an eye on the output transformer, make sure it's not getting too hot and there's not too much current flowing through it. I'll mount this back on the chassis later just for appearance sake, but I'll leave it off for now. It just shaves a little weight off the chassis, which is nice while I'm working on it. Alright, so next up I am going to start rebuilding these Bakelite blocks. When I did my Philco 60, I removed all of them at once, rebuilt them, and then put them all back in. I don't recommend that, and I'm not going to do it again. The problem was after I removed them all and restuffed them, that was great. I mean, I made like a little assembly line and just did them 1, 2, 3. But when it came to putting them back in, I had to constantly refer back to notes and photographs to see which one went where and how it was all wired in. So I'm just going to take one out. Take a picture first, take one out, rebuild it, then put it right back in and hook the wires back up before moving on to the next one. Most of these only have one capacitor in them, so I think it'll go pretty quick. After I finish all the Bakelite block caps, I will restuff the 4 paper caps, and then finally the electrolytic can. I'm going to do something a little bit different on this set though. I'm actually not going to use electrolytic capacitors to restuff this. I'm going to use polypropylene. I was digging through my parts and I just happened to find this 10 microfarad 250 volt cap. And it got me thinking, why not use it? It calls for an 8 microfarad at 100 volts, so a little bit more capacitance isn't going to hurt anything, and the higher voltage is fine. And the other 2 sections are, let's see, I think 4 microfarad and 2 microfarad. Yeah, so a 2, a 4, and an 8. So when I ordered my parts from Mauser, I got a 4.7, which is the closest equivalent you'll find these days, and a 2.2. So 2.2, 4.7, and a 10. I was pleasantly surprised that when I ordered these, they're exactly the same brand and type as the one that I already had, which I pulled out of, I have no idea what, some type of industrial control board. Got a couple of these guys. And all these will fit inside this cam pretty easily, so I think it'll be kind of nice. Now, if you're wondering why would I use these and not use electrolytics, basically because I can, and these will last virtually forever. Modern electrolytics, well, do go bad, as you may have encountered yourself in LCD displays and computer motherboards and such, where they start bulging on top. So even with the highest quality ones, they will eventually go bad, and a lot sooner than these ever will. Here's an update on the cabinet. After the stain dried, I sprayed it with a couple layers of sanding sealer and sanded it smooth with 600 grit sandpaper. And then I decided that the stain wasn't quite the right shade of brown, so I gave it a light dusting of some medium brown walnut toning lacquer. And then a couple light coats of clear gloss deft lacquer. Once this sets up for a couple days, I will mask off the entire center area and spray the sides, top, and all the trim with this extra dark walnut, which will make this really, really dark and hide all those grain. It'll actually be almost black, but that's the way it was originally, and I think it'll look really good. One funny thing cropped up while I was working on this. As I think I mentioned earlier, I had to replace the wooden support on the back here on this side. Now, the piece of oak I used was about twice as thick as what was originally there, and when I went to slide in the chassis, it wouldn't fit, because this was jutting out too far, so I had to take a chisel and cut back about a 1/16 of an inch, or maybe even an 1/8 of an inch down here. Now the chassis will actually fit back into the cabinet, but there's still plenty of oak here to provide support for the side. The lacquer on that front center panel has cured up sufficiently for me to mask it off. And now I will finally start spraying the sides with this extra dark walnut toner lacquer. Now, unlike the other toner lacquer I used in the front center panel, this is a pigment-based toner. That was a dye-based toner. The dye-based toners are kind of more like stain in that they let the grain show through. These pigment-based stains are opaque. So with just a couple light coats, it will pretty much completely obscure all this grain, and that's how the original set looked. This wood on the sides is not meant to be anything fancy that you'd want to look at. This is sort of an early form of plywood, and it's meant to be covered up. I've got about 4 very light coats done. I think a couple more will do it. One thing you got to make sure of when you spray stuff like this, especially when it's very dark, is to get at all the different angles. Like, for instance, I just noticed it's a bit lighter in here, and so on. Like, I was very careful to actually spray the inside edge along here, and I even turned it upside down to make sure I got the bottom edges of the feet, the front lip, and so on. Alright, after about 8 light passes, I'd say this is completely and thoroughly covered. So, now the moment of truth. Let's take the paper off. You want to be careful when you take this tape off to not just rip it right off, or you could pull up the underlying finish. So go slowly at a bit of an angle. Alright, looks good to me. Bottom. So none of that dark color leaked through. Got nice crisp lines all around. A little bit of residue here and there. I'll use some mineral spirits to clean that off after this lacquer's cured a little bit more thoroughly. And then I will start putting on some finished clear coats of gloss lacquer. I let the lacquer cure overnight, and I was about to put on a nice new Philco decal, but it turns out that this font isn't quite right. It's too large and the letter spacing isn't right, so I'm going to order up the right kind, which is just as well because I need to order up some other stuff anyways. I'm going to be getting them from Radio Days, which has now moved to a new website, radiosupply.com. I'll be using the set that I think is called the Hi-Fi set or High Fidelity set, which has Philco with, I think, the word high fidelity below it. The high fidelity is wrong, so I'll be clipping that off, but the Philco size and spacing is close to the original. Not perfect, but close, so I'm going to go with that. In the meantime, I'll continue working on the radio to get this thing actually playing.